Let's now determine the side lengths of this equilateral triangle with the side lengths given as shown in this equilateral triangle. So in an equilateral triangle, we know that all the three sides are congruent. So therefore, this side with the side length 3x plus 6 is congruent to this side with the side length 6x minus 3. Also congruent to the third side with the side length 9x minus 12. So we can write down this equation as 3x plus 6 equals 6x minus 3 equals 9x minus 12. So now we have to solve for x. So I consider one of this as equation, or I could also consider the other part as the equation to solve for x. So here I'm considering 3x plus 6 equal to 6x minus 3. So first I subtract 6x from both sides. So when I do that, I get 3x minus 6x plus 6 equals 6x minus 6x minus 3. So we can cancel this 6x, negative 6x. This becomes 0. Therefore, we have 3x minus 6x is negative 3x plus 6 equals negative 3. So we have to solve for x. So we subtract 6 from both sides. So I'm going to subtract 6 like this. And when I do that, I get negative 3x equals negative 9. Now I divide both sides by negative 3 so that I solve for x. So I divide by negative 3. This negative 3 cancels with negative 3 as plus negative 9 cancels with negative 3 as 3 times. So we can say that x equal to 3. So we have determined the value of x, which means we can substitute in any one of the sides because all the three sides are congruent. So we plug in the value of x equal to 3 in one of the sides to determine the side length. Let me plug in into this one. So this is 6 times of x minus 3. When I plug in, it becomes 6 times of 3 minus 3. This is equal to 6 times of 3 is 18 minus 3 gives 18 minus 3 is 15. So therefore the side length of this equilateral triangle is 15. We can in fact verify by plugging in one of the other sides. Suppose if I plug into this side, this becomes 3 times of 3 plus 6. This gives 3 times of 3 is 9 plus 6 equals 15. So here also the side length is 15. In fact, when you plug in into this side length, we will also get the side length as 15. So therefore the side length of this equilateral triangle is 15, and this means choice B is the correct. Let's now do this question number 16. Here we have a triangle NOM, and in this the segment OP bisects the angle MON. So we know from the fact that any angle bisector divides any angle into two congruent angles. Suppose we have a ray like this, and the angle between this ray is, let's say this is 30 degree, and if there is an angle bisector, so we draw an angle bisector like this. This angle bisector divides this total angle between these rays into two congruent angles. That means it divides exactly into two equal parts. So we can divide this 30 by 2 and see that this angle is 15 degree as plus this angle is also 15 degree. So this is some information about the angle bisector. We will utilize this concept and solve the value of x. So coming back to our triangle, since OP is the angle bisector of angle MON, we know that this angle is congruent to this angle, that is angle NOP. I can write down this as angle NOP. This angle is congruent to angle MOP, since the segment OP is the angle bisector. This implies the angle of NOP is given as 2x minus 10. This is in degree. and this is congruent, we can put equality. This equals the angle x plus 15 degree. So now we will solve this for x. I'm going to subtract x from both sides. So I do like this. I put negative x and then I put negative x. So when we do the subtraction, we see that 2x minus x is, we have x minus 10. This is in degrees, is equal to this positive x and negative x will get cancelled, and we simply have 15 degree on the right side. Now we add 10 degrees to both sides. So we put like this, and when we add, we see that this positive 10 degree and negative 10 degree will get cancelled, and we will have only x on this left side, and this is equal to 15 plus 10 is 25 degree. So therefore the value of x equals 25 degree, which means the choice B is correct. Let's now determine the median of this given triangle IHJ. So here we have three line segments, that is IK and GL as well as HG. We know that from the definition of a median, median is basically a line segment that joins the vertex with the midpoint of opposite side. So suppose if I consider this as a triangle, we have three vertex for this for any triangle. So let's consider one of the median. So I draw a line starting from the vertex to the opposite side, and this joins the midpoint of the opposite side. That is, this, if you consider this M as the midpoint, this is the median. So let's say this is A. AM is the median of this triangle, where M is the midpoint of the side BC. So it basically bisects the side into two equal parts. So this is some information about the median. Now let's uh, find the median for the given triangle. So here we have this line segment IK is one of the line segment, and we also have HJ, this is another line segment, and GL is also another line segment. Let's identify which line segment is the median. So if you look at the IK, from the vertex, it is connected to the opposite side, but the angle that forms it forms with the opposite side is right angle, as it is indicated by this small little square. So this is basically an altitude of this triangle. Any line segment which is drawn from the vertex to the opposite side with 90 degree is called as the altitude, or in fact the height of the triangle. Now let's look at the segment HG. So this is the segment from the vertex H to the opposite side IG and intersecting at J. In fact, J is basically the midpoint of IG, because we see that small ticks, this one as well as this tick. So this indicates J is the midpoint of IJ. So this is a line segment which joins from H, one of the vertex, to the opposite side, which is the IJ, to the midpoint of the opposite side. So basically HJ is the median of this triangle. We will also understand this another line segment GL. So this is the line segment from the vertex G, and it is drawn to the opposite vertex with indicated as L. So basically GL is the segment. However, when you look at this vertex, it exactly divides the angle into two equal parts. So this is basically an angle bisector of this triangle. So therefore, from our observance, we see that HG, the line segment HG, is the median of this given triangle, and this means choice D is correct.